One other type of challenging problem you might encounter is what happens if the variable you're trying to solve for is in two terms. Like this one has an a in this term, and this one also has an a in it as well. So we start off pretty similar to what we did in the previous problems where we were solving for a variable. We want to get everything involving that variable to one side and everything not involving a variable to the other side. It doesn't really matter which side you pick, you just have to be consistent. So I am going to pick this side to have all my variables involving a, and this side to have all my variables not involving a. So this side is supposed to have no a, and this term does have an a, so I will get rid of it by subtracting that term from both sides. This does not involve an a, so that's okay. And then I move over to my a side. This involves an a, so that's okay. This does not involve an a, so I want to get rid of that. So I'm going to add y to both sides to get rid of that. Then ax minus ax is 0. Negative y plus y is 0. And then I write my result. Z plus y is equal to aw minus ax. Now on the right side, both of my terms involve an a. Since they have a common factor of a, what that means is I can factor out an a out of each of those terms. So if I factor out an a out of the first term, I'll be left with a w. And if I factor an a out of the second term, I'll be left with a negative x. The left side will stay the same for the time being. Now I only have one a, and my a is being multiplied by something. So to get rid of that, I would need to divide both sides by that factor. So I divide both sides by w minus x, and then w minus x divided by w minus x just gives me a. So my final answer will be z plus y over w minus x will be equal to a. We'll look at one more example like this. In this problem, we are trying to solve for y. So this is a combination type problem where I have a couple of steps because the first thing I want to do is get rid of my fraction. So to get rid of my fraction, I want to multiply both sides by my denominator. Because y minus 1 divided by y minus 1 will give me 1, and that will cancel out or go away. On the left side, what I'm going to do then is do the distributive property to multiply the x by both of those terms. So x times y is going to give me xy, and x times negative 1 is going to give me negative 1x or negative x. On the right side, I'll end up with y plus 2. Now, this is just like the last problem. Since I want to solve for y, I want to get everything involving a y to one side and everything not involving a y to the other side. In this case, I'm going to move all my y's to the left side. So I'm going to subtract y from each side to move all my y terms to the left side, and everything not involving a y to the other side. Since this x does not involve a y, I'm going to move that to the other side. Then negative x plus x cancels out, y minus y cancels out. The left side becomes xy minus y, and the right side becomes 2 plus x. Then this is very similar to the last problem, where both of my terms on the left side involve a y, so I can factor a y out of those terms because it's a common factor. If I factor a y out of the first term, I get x. If I factor a y out of the second term, I would be left with negative 1. Now I only have one y, and it's being multiplied by x minus 1. So to get that by itself, I divide both sides by x minus 1. X minus 1 divided by x minus 1 is just 1, so I get y by itself is going to be equal to 2 plus x over x minus 1.